Hi, I am Arib. You are watching my YouTube channel. Vacuum circuit breaker. Definition of VCB. The vacuum circuit breaker, VCB, is a switching device capable for operational switching, on-off operations, of individual circuits or electrical equipment in normal or emergency modes with manual or automatic control. Made for a medium voltage of over 1 kV based on the principle of quenching an electric arc that occurs when the contacts open in a vacuum gap. The development of power engineering and the transition to higher operating voltages required the development of switching technology, especially switches devices capable of interrupting short-circuit currents. Simply opening the contacts in the air did not solve this problem. New technologies were needed. The range of operating voltages used in the power industry is increasing, and this growth is now supported by the economic benefits of switching to higher transmission voltages. The first vacuum circuit breakers took the approach of all circuit breakers and used bulky spring motor actuators to open contacts. Such drives had a large number of loaded friction units, which significantly reduced their resource and reliability. The early developers of vacuum circuit breakers underestimated the advantage of vacuum in the form of the ability to operate with small gaps, which allowed for more energy-efficient actuators. A vacuum circuit breaker, VCB, is a type of circuit breaker that uses a vacuum as the arc quenching medium to interrupt the flow of electrical current in a circuit. Vacuum is a superior dielectric and the best medium for arc extinction in circuit breakers. For medium voltage, example up to 38 kV, the vacuum circuit breaker is considered the closest to an ideal circuit breaker. The illustration on the right shows the formation of an arc when the contacts of the VCB open. When the current-carrying contacts are separated in a vacuum, an arc is formed between them. Hot spots are formed intensely during the separation of the contacts, from which metal vapors rapidly emerge, leading to the establishment of plasma. The amount of vapor in the plasma is suitable for the rate of emission of vapor from the electrodes. Example, the amount of arc discharge depends on the amount of interruption current. This envelope is an important part of the VCB, and it becomes a vacuum during operation. The movement of the moving contacts inside the interrupter unit is facilitated by metal bellows. The arc extinguishes at the zero position of the AC wave with the next current. Immediately after the nipple current becomes zero, metal vapors condense. Dielectric strength builds up rapidly, and the arc restriking stops. This principle is used in vacuum circuit breakers. In a vacuum circuit breaker, two contacts, a fixed piece and a moving one, are placed inside an insulating envelope. The air inside the insulating envelope is completely removed, and the envelope is sealed. One human benefit of a vacuum circuit breaker is that during separation, the moving contact has to cover a very short distance, a few millimeters. Stopping the current is very easy and fast. Vacuum circuit breakers typically have one or more cylinders per pole consisting of interrupters. For voltages up to 36 kV, single interrupter VCB are usually used, and for voltages of 725 kV and above, multi-unit VCB are made.